In this video, we are going to talk about the repetition model. So here's setup. You are the boss, the decision maker, and you know there are two states of the world. One is A, one is B. And you believe that A is more likely to be the case, but there is non-negative chance, to be exact, 1/3 of the chance that B would occur. And you hire an analyst to tell you whether or not the state of the world is A or B, and you will make a policy accordingly. So the chance that you will hire a good analyst is 3/4, and the chance that you hire a bad analyst is 1/4. When you hire the analyst, you know nothing about whether or not he is actually good or bad. So this is a prior belief. So what's the good analyst? What is a good analyst? The good analyst learns the state of the world for sure. So in this case, let's mathematically formulate that. It says that if I'm a good analyst, when the state of the world is A, I receive a signal that says it's SA with probability 1. Okay? It implies that when the state of the world is A and I'm a good analyst, but I receive a signal B, is 0. So I cannot make a mistake. Okay? If I truly make effort, I will not make a mistake. Same thing here. If the state of the world is actually B, good analyst will tell you that it's world B. So it will not get a different signal. Okay, so what's a bad analyst? Bad analyst basically know nothing, so whatever the state is, he just tosses a coin. So that means, so from here, what do we mean that when the state of the world is actually A, he tosses a coin and have a chance he will recommend, he will say it's A and have a chance he will say B. So essentially, you will have this. Okay, so now let's see what would happen if the state of the world is actually A. So now let's say you get from the analyst that he said the state of the world is A. What do you learn? First thing you want to learn is that what is actually the probability that it is actually the word A. Okay, so when we write out the Bayes rule, we need to know what is the conditional probability that analyst will see signal A when he actually see state of the world is A. So we do not know that because we do not know whether or not he's a good analyst or he's a bad analyst. So we need to consider both situations. Okay, that is why we need to we need to sum over the two scenarios, when it is a good analyst and when it is a bad analyst. And this step is what we call marginalization. We go from a joint distribution of SA, the signal, and the type of analyst to be only the signal. There is no type of analyst. And we can get the joint distribution of signal and the type of analyst by using the conditional probability again. Okay, so here I also want to point out that the fourth step here should be PGA conditional A, but we make the implicit assumption that the type of analyst has nothing to do with the state of the world. So this is just going to be reduced to be PGA. And from here, we know that every ingredient we need here can be get from the setup. Okay, so PSA a conditional AGA we know from the description of the good analyst. So you're gonna just plug in the value and you will get the final value. So now let's calculate it for the rest of the quantities. So we can use the same formula to calculate what is the conditional probability of recommending SA when the state of the world is actually B. Okay. Although notice that although these two numbers sum us to be 1, this is only coincidence. In general, PA conditional on B will not be the complementary of PA conditional on A complementary. So that's just basic statistics. So now we can plug in the value and calculate the posterior belief of the state of the world conditional on analyst recommend A. So we know that when the analyst says it's actually word A, it is very likely that this will be the truth. So what does this tells us? So this tells us that when the analyst truthfully report the state of the world, it's good for decision maker because now their accuracy of their belief raised from 3/4, 2/3 to 14/15, which is a big jump. So that's good for decision maker. But that is not the only thing that decision maker learns. Decision maker also learns what is a type, what's the chance that your the analyst is a good analyst when he said the state of the world is A. So now we are going to also calculate that. So we are going to still use the same strategy. First, we're going to express the conditional probability by a Bayes-through. Then we need to figure out what is the conditional probability that you are a good analyst. What's the probability that you will say state of the world is A when you're a good analyst, and what's the probability that you will say state of the world is A when you're a bad analyst. And again, we're using the trick of marginalization when we marginalize over the type of the state, and we get the joint distribution of signal and state by using conditional distribution we get from the from the setup. So and you can calculate, plug in the numbers here. So here I basically did a trick, is that we know that from the setup that no matter what the state of the world is, there's only half of the chance that I'm going to, if I'm good at analyst, I'm going to say A, and half the chance I'm going to say B. So when you're a bad analyst, the probability that you will say A is just only always 1/2. And then when you plug in the number, you get the posterior belief of good analyst conditional on I say the word of the state of the world is A. It turns out to be 4/5, which is larger than 3/4. So what does that mean? That means that saying state of the world is A is good for your reputation. The reputation here means the belief other people have that you are a good analyst. So that is a reputation. And by saying state of the world is A, it helps your reputation. Okay, so that's the, in this case, it's good because when you say A, the decision maker learns something valuable about the state of the world, which is it's more likely to be A, and it's good for your reputation because you actually raise the probability that people will think you are a good analyst. So now we are going to do the same thing for saying signal B. So we're using exactly the same step as we used before in analyzing the signal A, and we use the Bayes-through marginalization, then using conditional probability, and we get all the ingredients we need. So let's jump directly to the result. If I believe that the analyst will be truthful, and when I see that analyst says state of the world is B, the decision maker will actually update their belief that the state of the world is actually B to be a very significant number, okay, which is way larger than the prior belief. It thus indicates that the decision maker actually gain a lot from this signal. So it's very valuable to help the decision maker learn what the true state of the world is. However, saying B is to the detriment of the analyst, because now the posterior belief that you are a good analyst reduced to 2/3, which is smaller than 3/4. Okay, which is not surprising because look at this number. if you're a good analyst, the chance that you will say that the state of the world B is actually relatively small compared to what you will be a bad analyst. So intuition tells you that you should believe that this guy is more likely to be a bad analyst. Although when he is good, he is very informative. Okay, so now this is incentive incompatibility right here, because although it's good for the analyst to be truthful, for the decision maker, it is bad for himself, because now everybody else will think he's a bad analyst. So the moral of the story here is that when you have a when your agent has a reputation to maintain, it is actually good to reduce the transparency so that he does not need to yield to public pressure. But if your boss is exactly the people you're going to impress, then this problem has no solution, because you cannot hide the recommendation of the analyst from the decision maker. So that is the gist of the repetition model.